Hello, good evening all. So I am audible. Please just confirm whether I am audible or not, or slide is visible or not. Week number 4, assignment year 2025. Is it visible? You can write in the chat box also. Then we'll proceed with the first question. Okay, thank you. So the first question is your, let me just read. Under what condition does the flow separation take place? When your dp by dx greater than 0, when dp by dx less than 0, when dp by dx equal to 0, and d not a function of dp by dx. Means this is not depend on the your dp by dx. Here p is your pressure. Remember please, p is the pressure and x is a longitudinal direction. So now you just try to think on that, or in which condition your separation will take place in the boundary layer. So now you can write your answer in the chat box, which option will be correct, whether A, B, C, D. Just think on that please and just try to write your answer. If you not know, you can just Google also, because this is a discussion class here. This is not your exam and all. So you can Google also such type of questions. So might be you will be remember for a long time. So please just try to write your answer in the chat box. I'm waiting. I'll wait 2-3 minutes. Maybe other student will join. So in between you can try to think on that. The question number 1. This is your from boundary layer separation. Very important question. I'll wait another 2 minutes. Okay, you are telling A option when the pressure is greater than, that is the pressure gradient is greater than 0, means positive. Okay, fine. Ghost is telling A option. Okay, fine. Other student, please also you can write your answer. Okay, so let me just explain you. So here, yes, option A is correct. When your pressure is the pressure gradient is greater than 0, then you can say your boundary layer will separate. So what is actually the meaning? Let me just explain you very conceptual way. So you know the Bernoulli principle. Basically, your P by your pressure plus V square by 2Z plus your datum, which is constant, equal to constant. So from here, if your datum will be fixed, so this is your constant. So then what will happen if your pressure will increase for constant value, then your velocity should be decrease. Then you will get the constant value. If your pressure is not changing, then your velocity should also not changing. Not zero, should also not changing. If your pressure is increasing, so velocity decreasing. If your pressure is decreasing, so your velocity should be increase. That's why you will get the constant value. because you have to have constant. Means you are getting the 5 value, say. If you are getting 5, then if it is, this is 2, this is 3, so this should be 2. If this is 2, this should be 3. Only you can get the 5. So this is the meaning. If this is not changing, if this is 3, so always this will be the 2 for getting 5. If this is the fix, datum is fixed. So here is the meaning is this. Now what I am trying to say you. So this is a basic understanding from your Bernoulli. So now let me just explain you what I am telling. Let us suppose you have a surface or a cylinder like that, and the direction of x is in this direction. When your fluid is moving, or you can say the air or water, whatever, then what will happen? The here what is happening, your the acceleration will increase. Here your velocity will be accelerate due to at this point your velocity will accelerate. Velocity means increasing, so your pressure here is decreasing. As you know, the flow from higher pressure to lower pressure up to this. After that, what is happening? Your velocity decelerate, means your velocity decreasing. So in here, your pressure will increase. So in this region, you will observe the separation. Your boundary layer will be like that up to here, and after that it will be separate like that. So remember please. So this is a boundary layer separation. So remember always up to your, means the meaning here is you have to always remember once your velocity will increase, means once your fluid will accelerate, then pressure will decrease. You can also remember like that the the flow always occur from the high pressure to low pressure. So here high and up to here is a low, but after the fluid is decelerate, so your the pressure gradient will increase. So like that you can remember. So option A is correct here. Always remember please, the fluid separation occur when your pressure gradient will greater than 0. So for more conceptual understanding, you follow please NPTEL video, whatever sir is taught very clearly, sir has explained everything. So now we'll move on the next question, question number 2. What is the consequences of a strong adverse pressure gradient in boundary layer flow? What is the consequences of a strong adverse pressure gradient in the boundary layer flow? Option A, decreased drag. Option B, delayed separation. Option C, reduced boundary layer thickness. Option D, early boundary layer separation. So you have 4 options. Just think on that. What will be the reason? Very important question, please. Everyone just think on that. So you have 4 options, please. The strong adverse pressure gradient in the boundary layer flow. Here the adverse pressure gradient means nothing. This is your greater than 0. Whatever in the first question I was discussing, the same thing here. But you need to understand. You need to understand fundamentally what is happening. Whether it is due to the delayed separation, or just think on that. Then I'll explain. You have 2 minute time, so please just think on that. The question is, when you have the adverse pressure gradient, means when you have the pressure gradient greater than 0, what will happen? Whether the drag decrease, delayed separation, reduced boundary layer thickness, early boundary layer separation, what will happen? So this is the question. Very important question. Just please try to write your answer in the chat box. I'm waiting. Okay, so let me just explain you. So what will happen actually? Early boundary layer separation you will see when you have a strong adverse pressure gradient. Means, as you know, as your as soon as you will get the pressure gradient greater than zero or adverse pressure, then what will happen? Your boundary layer separation will happen fast, as soon as possible. If you are As soon as you are getting your the pressure gradient greater than zero, as soon as your boundary layer separation will happen. So this is a very simple question. So now we'll move on the next question. So increasing drag, also remember please. Next question is question number 3. So here the velocity u in turbulent boundary layer varies as directly proportional to y to the power 1 by 7. For this profile, the ratio of delta by x varies as, you have to write, you have to just tell the answer. Option A, REX, x here representing the direction, means distance it is representing. So to the powers minus 0.1, here is the power 0.5, 0, here is the power minus 0.5, here is the power 0. Minus 0.2. So just think on that. And here delta, remembering delta is your boundary layer thickness. This is your boundary layer thickness. Just try to, okay, you are telling the question to option D, fine. Okay, for question 2, yes, option D was correct. So for question 3, please just try to think on that. Or you can also Google if you are not able to understand, if you are not able to remember or recall your answer. So you can just Google, please. Just try to write your answer, please. Okay, so here your answer for this question. Your r to the power, remember please, this is the formula. Formula for your boundary layer thickness. So always remember, for one, as per the 1 by 7th power law, your delta is equal to boundary layer thickness 0.376 x r to the power minus 0.2. So from here you can write delta by 6 is directly proportional to re to the power minus 0.2. So this will be your correct answer. So here option D is correct for this question. Now we'll move on the question number 4. Okay, so question number 4 is the velocity distribution in a boundary layer is given by u small u by capital U is equal to y by delta, where u is the velocity at a distance of y from a boundary layer from the boundary, and u is equal to capital U at y is equal to delta. So delta being boundary layer thickness, okay, then the value of momentum thickness will be. So here you need to calculate the momentum thickness, and you have the relation small u by capital U is y by delta, where u is the your velocity at distance y from the boundary layer, from the boundary actually, not boundary layer, and u is your, the capital U is your, when your boundary your, that is y reach up to the complete thickness, means you can think like that. So if this is your thickness delta, so here is capital U, and somewhere you are getting at y, so here is U. So this is like that. So here you need to calculate the momentum thickness, and you have the four options: delta by 2, delta by 4, delta by 6, delta by 8, or del you can say. So please just try to write your answer in the chat box for this question. For question 4, you are telling option B is correct. Okay, delta by 4. The other student, please also try to write your answer. Okay, so let me explain you. So here you need to calculate the momentum thickness. So what is the formula of momentum thickness? Let me just show you the answer here. So this is the formula. Remember please for momentum thickness. So now delta small u by capital U 1 minus small u by capital U dy. So here you have to put 0 delta and y by delta 1 minus y by delta dy. So now you can integrate here. So if I integrate 0 delta your y by delta minus y square by delta. So now you can dy. So now you can write y square by 2 delta minus y cube by 3 delta. Here also delta square. So now what you will get at now here you need to calculate, then the value of the momentum thickness will be at y is equal to delta. So let us put here the delta at y is equal to, when we will put the delta, so delta square by 2 delta minus delta cube by 3 delta square. So delta will be cancel out, so here is square, so 1 delta will be remain, and so you will get delta by 2 and delta by 3. So after the calculation you will get delta by 6. So option C is correct here, please remember. Option C will be correct here for question number which was question number 4. Yes, question number 4. Option C is correct, delta by 6. So now let us move on the next question. Next question is question number 5. So please just read the question. Hello. Yes, sir. I'm in class, sir. I'm in class. 7 minutes. 7. Okay, sir. So here you have question number 5. In a laminar and turbulent boundary layer over the entire length of plate, the boundary layer thickness at the distance x from the leading edge varies respectively. So you have to tell here for the laminar boundary layer and for the turbulent boundary layer also. So option A here, x to the power 1 by 2, x to the power 1 by 5. Similarly here you can see x square, x to the power 1 by 7. Option C, x to the power 4 by 5, x to the power 1 by 2. And option D, x to the power 1 by 2, x to the power 4 by 5. So you have to tell, let me just explain you what is laminar. So here laminar, then transition, then your turbulent boundary layer. So please just try to explain or try to give the answer actually. The your boundary layer thickness, in the spelling mistake, at the distance x, if this is your distance x from the leading edge varies respectively. So delta for laminar directly proportional to what, and delta for turbulent directly proportional to what. So just you please think on that. Which option will be correct for this question? You can write your answer in the chat box. For question number 5, you are telling option A. And previously, okay, fine. So, okay, we'll see. The other student, please also try to participate in the chat box. You just try to write your answer. So, Bala Murugan is telling A option. Okay, fine. Good. So actually, how your fluid look like in the laminar boundary layer thickness, little bit ordered flow here. In transition, circulation is slightly circulation like that. Remember, please. This was observed during the experiment, and in the turbulent boundary layer, your fluid is like that. Remember, please. The lot of eddies formation. So like that. This is your laminar, this is transition, and this is turbulent. So now here you need to tell how your delta varies. Delta means this. What is here? Delta. What is here? Delta. What is here? Delta. Means what is here? Delta. Delta laminar. So this is delta laminar 1, delta laminar 2, delta laminar 3, delta laminar 4. So how this related with the x? Whether it varies x to the power half or x to the power square, x to the power 4 by 5, x to the power 1 by 2. Similarly for turbulent. So hope you understand the question very clearly. Now please just try to think. Okay. Deep is telling D option. Okay. X to the power 1 by 5, and for turbulent x to the power 4 by 5. Fine. Okay. Other student, please also you can try to write your answer. If you not know, you just Google. You can Google, please. Then you will remember for a long time. It's very, very important. Okay, so let me just explain you. Let me just show you the answer. So yes, here option D is correct for this. So your delta laminar varies x to the power 1 by 2, and your delta turbulent is vary x to the power 4 by 5. So remember, please. Very important question. You might be expect questions, such type of question in the your final exam, NPTEL, or also another competitive exam. So here detail solution also given. Okay, fine. So detailed solution is, let me just explain you. So this is your for laminar. So delta is equal to 5x divided by root RE. And you know RE is nothing but, in case of the plate flow, your rho u x divided by dynamic viscosity. When you will put here 5, this is your 5 x, and you will get here the rho u x divided by mu. This is your root. Okay. So this is 5. You can write x like a square root into a square root divided by your square root x, then another constant. So x will be cancelled out. So your delta in case of laminar is directly proportional to root x. So you can also write 1 by 2. So this is your final. Similarly here you can think like that. For this x to the power 1 you have, and x to the power 1 by 5 have. Because RE is your directly proportional to x. So at the place of RE for such type of getting the relation, you can write x to the power 1 by 5. So from here you can write x to the power 1 minus 1 by 5. So from here 4 by 5 you will get x to the power. So option D is correct here. Remember please. For question number 5. Next question. Question number 6. So boundary layer separation is associated with continuous loss of energy, momentum, mass, all of the above. Boundary layer separation is associated with continuous loss of energy, momentum, mass, all of the above. All of these. So please just try to think on that and try to write your answer in the chat box for question number 6. Hope you all understand the previous question. So now just try to think about the question number 6 and write your answer in the chat box. Okay. For question number 6, you are telling Balamugan is telling option D. Fine. All of these. Boundary layer separation is associated with the continuous loss of. So as you know, as in the first question I was discussing, I was relating the your boundary layer separation with the this your Bernoulli equation. So hope you understand the Bernoulli equation is the conservation of energy. So okay, just you think on that. Other people also think. Then I'll explain you. So what will be the correct answer? I'm expecting the answer from all people. You whatever you have joined. I'm expecting. Please. If you not know, you can. Okay, Shreya is telling option D. All of these. Fine. Other student, please also try to write your answer, whatever you know. If you not know, you can Google, please. I always encourage you. If you not know, always you can Google. Okay. Let me just show you. So here option will be the correct option is energy only. Why? The eddy formation during the flow reversal the cause continuous loss of energy during the boundary layer separation. So what I was discussing, your boundary layer separation was I was relating with your energy, that is your Bernoulli equation, which is your which is based on your conservation of energy. So here the momentum mass not loss, only energy losses due to the eddy formation. As in the previous question also I was discussing here, the you in the turbulent flow, the flow in the laminar will be very ordered flow, but in the transition little bit not very ordered, but in the turbulent flow you will see the lot of eddies, and eddies is nothing but is your loss of energy. Eddies try eddies actually try to lose the energy of your flow, so it is related with the energy. Now we'll move on the next question, question number 7. So in laminar boundary layer, the velocity distribution can be assumed to be given in usual notations as u by v is equal to y by delta to the power 1 by 7. Which one of the following is the correct expression for the displacement thickness delta star for this boundary layer? So you have this time your u small u by v, or you can say the free stream velocity, that is capital V, is equal to y by delta to the power 1 by 7. So what will be your the displacement thickness? Previously we have already solved your momentum thickness. Now you have to tell your displacement thickness. Just try to calculate and try to write your answer in the chat box, please. For this question you have uh, okay, for previous question I think you are telling A option, Kagan. Okay, A option was correct. Now for question number 7, you just try to write your answer in the chat box. You have 5 minutes. Just think on that, how you will calculate, and calculate very with patience. Here you need to have some patience for the calculation. Okay, so Ghosh is telling D option, delta star is equal to delta by 8. Okay, fine. Other student, please also try to write. Okay, Shreya is also telling D option, delta by 8. First to try to attempt with yourself. If you are not able to, then you can Google. Because finally, you have to solve with your own hand in the exam. So you have to remember these things, this point also. So first try to solve with your own mind. Then if you not know, you can take the help of Google, any AI software, any AI website. Okay, so now let us discuss the question number 7. Okay, by integrating the equation, option is D. Okay, fine, that is good. You are telling D option. Okay, Deep is also telling that D option is correct. Fine. So now let me just show you. So for other student, okay, option D is correct. But the what is the formula for displacement thickness? The formula is here written very clearly. 0 by delta 1 minus small u by v. So now here you can put the formula. The equation value 0 by delta 1 minus y by delta to the power 1 by 7 dy. And after calculation you will get delta by 8. This is the correct answer. Okay. So how maybe some student not know how to. Okay, for few students let me just integrate. So 0 by delta your dy minus 0 by delta y by delta to the power 1 by 7 dy. So now you can write here. You will get the y minus y to the power 1 by 7 plus 1 divided by 1 by 7 plus 1 delta. And when you will put here y is equal to delta, then you will get finally delta by 8. Okay, so now we'll move on the next question. Question number 8. The boundary layer exists in which of the following? The flow of real fluid, flow of ideal fluid, flow over surface only, and pipe flow only. The boundary layer exists in which of the following? You have to select most appropriate. Only one option here is correct. So you have to select the most appropriate answer. Think and try to write your answer in the chat box. Okay, for question number 8, you are telling C. Shreya is telling C option. Flow over flat surface only. Here it is written only. Please just think on that. Whether you will get on the another surface, curved surface, whether you will get or not boundary layer. Just think on that. Because here it is written the a flat surface only. So it is the correct answer. Okay, option A you are telling the Balamugan. Okay. Flow of real fluids. Fine. Other student, please also try to think and try to write your answer. Kagan is telling A option. Flow of real fluids. Okay, fine. Okay, so let me just explain you. So boundary layer exists in which of the following? Flow of real fluid, flow of ideal fluid, flow over the flat surface only. No, not surface only. You maybe get on the curved surface, you maybe get on the flat surface, you maybe get on the airfoils. It is also your curved surface. So like that, you will get curved, flat or other type of surface also. But you have to have the real fluid. Always remember, this is the most appropriate answer for this question. The option A is correct for question number 8. Now we'll move on the next question. Next question is very simple. Okay. In laminar boundary layer, the shear stress in laminar boundary layer, remember please, the shear stress tau naught at any location x is given by which option? U by rho del v del u by del y at y is equal to 0 and b is equal to u del u by del y at y equal to 0, rho l square del u by del y square y equal to 0 and D option rho u dash v dash. Average, the average of v dash u dash. The question is asking about in the laminar boundary layer. Your tau. For 9 you are telling C option, okay. Balamugan, okay, fine. Kagan is telling B option. The question is asking here in the laminar, not in the turbulent. Shreya is telling B option, fine. U del u by del y, y equal to 0. Other student, please also you can attempt. Other student, please also can think about it. Which option will be correct? Okay, so let me just explain you. Your laminar boundary layer, in the laminar we are discussing, let me just give the example. You want flat plate, this is your laminar boundary layer, then after you will get the transition, then your here, then after you will get the turbulent. So in the laminar, I have told you already, the ordered flow, the flow will be in the layer wise. Here little bit the eddies, small eddies, the try to formation of eddies, but here the completely eddies formation. So remember please, we are discussing here, you need to calculate tau in this region for laminar, not transition and not turbulent. So you know one thing, this option is related with your turbulent. Why? Because of this was the Prandtl I was discussing in the previous class also. This was given. This or is your from also your turbulent. This was the Reynolds shear stress. Now, the only this is not a correct one. So only B option is correct here. Tau is U dynamic viscosity mu del U by del Y. This will be your correct option here. Option B will be correct for question number 9. Next question. Okay. So laminar sublayer exist only in laminar boundary layers, in turbulent boundary layers, only in smooth turbulent boundary layers, only in rough, fully developed turbulent boundary layer. So very precisely you have to think and just try to write your answer in the chat box. Which option will be correct? Very important question, please. Everyone, just think on that. B option, okay. Kagan is telling B option in turbulent boundary layers, okay. Bose is also telling B in turbulent boundary layers. Okay, Deep is also telling. Okay, hope option B should be correct. Let me just show you. Yes, option B is correct. In turbulent boundary layer, you will observe one laminar sublayer thickness. The laminar sublayer, also called the viscous sublayer, is the region of mainly turbulent flow, and that is near a no slip boundary and in which the flow is laminar. So where you will observe in the laminar, then your turbulent or transition, then turbulent. So in turbulent you will observe the laminar boundary sublayer thickness here. And why we tell? Because in which the flow is laminar, in which flow is ordered. Why? Because as you see here, also you tell this layer is viscous sublayer. The viscosity here is very very high. So due to the viscous effect, your flow like the ordered flow, layer wise flow, very thickness, very thin layer. Okay, fine. So now we'll move on the next question, that is from your week, the same week assignment 4, but year is different, 2024. Now here you need to tell in question number 1, let me just take the pen. Question number 1, what is the energy thickness for the boundary layer with velocity distribution U by capital U, Y by delta? So here you need to tell energy thickness, delta U, energy thickness, whatever you will write based on U, but you need to tell. Okay, so now for this question you have 5 minutes, so please just think on that and try to write your answer. For question number 1, this is your from uh, same hydraulic engineering assignment 2024. Now here you will see the similarity. Maybe some question will be the similar from your 2025. So when you will actually here I will show you another one 2023, then you will see the similarity. Based on that you will get if you are solve this all three set 23, 24 and 25, then finally in 2026 you are able to very easy, you will feel very easy for solving your assignment. Okay, option D is uh, Ghost is telling delta by 4. Okay, fine. Other student, please also try to calculate. Once here you will calculate in this live session, then your small mistake will be nullified. Otherwise, in the exam or in tech or test in your class or mid semester, final semester, might be you will face some mistake. So if you are solving here, then it will be fine for you. Okay. Morgan is also telling D option. Fine, delta by 4. So actually after this question, I'll take 5-minute break. So you can also take. Okay, so let me just explain you first. Option D, okay, fine. Deep is also telling. Okay, maybe option D will be correct. Let me just show you. Yes, option D is correct. But how? So the formula is for energy thickness. Let me just write delta E 0 by delta U, small u by capital U, 1 minus u square by u square by dy. Now you have y by delta, 0 delta y by delta 1 minus y square delta square dy. Then delta by 0 y by delta dy minus 0 by delta y cube by delta cube dy. Now y square, sorry, y square by delta, you have limit 0 to delta minus y to the power 4 by, here will be the 2, 4 delta cube, you have limit 0 to delta. Then after solving, let me just solve finally. Okay, so here delta square by 2 delta, so you will get delta by 2 minus delta 4 by delta cube So that will be cancel out. So delta by 4. Once we will, this will be the 4. Okay. 2 delta minus delta. So finally delta by 4. So option D is correct for question number first. Okay. That was your question number first. Now the second question is here. So now you just read the second question and try to find out the correct answer. I'll come back after 5 minutes. Okay. Kagan was also telling D. That is fine. So now for question number 2, you just try to think. I'll come back after 5 minutes. Okay, so question number 2. In turbulent flow, which of the following gives the exact velocity distribution? Whether your logarithmic distribution or the Blasius equation, power law with index varying, and the Prandtl's 1/7 power. Okay, so Bala is telling option A. That is fine. Other student, please also try to write your answer. I am waiting. Other student, please just think on that. If you not know, you just try to Google and try to find out the correct one. Okay, Ramesh is telling A option. That is fine. Okay, two student is telling option A. Good. Other please also try to attempt, try to think. If you are joining here, then you have to some, that is the contribution in the chat box. Okay, Kagan is also telling A. Okay, most of the student is telling A option, so hopefully A option will be correct. Yes, in the turbulent flow, your the flow distribution, mostly your logarithmic distribution. Always remember, please. So I'll just give you example in laminar and in turbulent. How your flow velocity we have. So this is your u and this is the depth, and this is your again u and this is your depth. So in laminar it is parabolic like that. In the laminar, here is the deep phenomena. Here will be the maximum, little bit less from here. This is a deep phenomena due to your the air resistance on the surface of the fluid. Now in case of the turbulent flow, here is laminar, that is your straight, and then after parabolic, then after your logarithmic. Straight, logarithmic, remember please, not straight. So this is your logarithmic and this is your parabolic, remember please. Now we'll move on the next question. For this, actually option A is correct. So always remember. So what is the ratio of displacement thickness to momentum thickness? Delta star by theta. For linear velocity distribution over flat plate. Over flat plate for linear velocity distribution. Like that. For linear velocity distribution. This is your u, capital U. This is your small u at the place. If this is y, and this is y, and this is your complete delta. So how I will write this linear relationship? So how I will write? So delta by u is equal to y by small u. So from here you can write small u by capital U, then y by delta. So this is your linear relationship. Now you just try to calculate which option will be correct. For question number 3, I have given you hint what is the meaning of linear distribution. Now one thing is remaining here, then you will feel more understanding. This is your laminar boundary layer. So in the laminar boundary layer it is very parabolic, but you know exactly what is varying the parabolic exactly, but here assumption is it is varying your linearly. Okay, no issue. So based on the question, you have to try to give the answer for question number 3. And this is written, actually how I have written this one. This is your based on the triangle, rule of the triangle. So if you not know, you just Google. If your triangle is like that, and here is the width, this is your capital B, this is your small b, and up to here, if your height is y1, and here up to this your height is y2, then how you will write? Y2 by B, capital B, Y1 by small b. Or you can write B by Y2, small b by Y1. So this is a law of triangle. So based on that I have written only. Because your linear variation look like the triangle. So that's why. Okay, Bala is telling option A, 3. Fine. Ramesh is also telling A option. Okay. Other student, please also try to write your answer in the chat box. Which option will be correct for question number 3? Other student, please just try to calculate, because already I have told you the formulas for displacement thickness in the first, in the 2025 assignment we have already solved previously. Their displacement thickness in the separate question and your momentum thickness in the separate question. But here you have to calculate separately and try to just find out the ratio of these two, displacement and momentum thickness. So I'll suggest you, after this class, you just try to find out or try to just Google search out what is your displacement thickness, the physical meaning, and what is the physical meaning of momentum thickness, energy thickness, boundary layer thickness. Everything you have to search out. Then you will feel some confidence in this topic. That is, boundary layer thickness is not an easy topic of fluid mechanics. So you have to have uh, more effort. When you will give the more effort, then you will get confidence on these topics, the boundary layer thickness. Okay, so let me just explain you. So not the formula, I'm not telling the formula of the boundary layer thickness, the concept, how the boundary layer form, what is the meaning, everything. Okay, so delta star, the formula, and the theta formula. For the delta star, I think 1 minus u by small u by capital U, and for this 0 by delta, and here is u by u, then 1 minus, hope I am correct. So let me just see the correct formula. Yeah, this is correct. So now you have to put here the everything. So let me first calculate the your this, the displacement thickness. So 0 to delta and 1 minus y by delta. So I'll just dy here. dy is okay. Now, so y minus y square by delta, and here is the limit 0 to delta. So finally you will get delta minus delta square by delta. So delta by 2. Now for the displacement thickness for theta what you will do, 0 delta y by delta minus y by delta, sorry, y by delta. So finally you will get y square by delta minus y cube by 3 delta. So again you have to put the limit. So finally you will get y by 2 minus y by 3. So 6 and 3y minus 2y. So finally not y, this is your delta. This is your delta. After putting the limit, y will convert in the delta. So finally you will get delta by 6. So here you can see delta by 2, delta by 6 is equal to nothing. Your delta will be cancelled out. 6 by 2, finally you will get 3. So option A is correct here. For question number 3, the option A is correct, remember. Now the question 4 is, in boundary layer developed along the flow, in a boundary layer developed along the flow, the pressure decrease along the downstream direction. Remember please, here pressure is decreasing. The boundary layer thickness would be tend to decrease along the flow, remain constant, increase rapidly along the flow, increase gradually along the flow. Okay, here I think mistake in the option. So you have to write the correct answer. For question number 4, your pressure decrease along the downstream. So what will be happen? So pressure is decreasing. Try to write your answer please. Okay, Ramesh is telling option A, fine. That is tend to decrease along the flow. Okay, so Bala is also telling A option. Okay, so I'll not take much time here. If yes, it is option A, the tend to decrease along the flow. With the decreasing pressure in the direction of flow, with negative pressure gradient, the boundary layer tends to reduce in the thickness. Now, question number 5. The laminar sublayer thin boundary. The laminar sublayer is a thin boundary layer formed just adjacent to the boundary in laminar flow, turbulent, transition or compressible. Which option will be correct for question number 5? I need answer from all of you, please. From all of your sides, I need the answer. Okay, Bala is telling B option in turbulent flow. Okay, Deep is telling B option. Everyone, please just try to write here, because already I have in the first 2025 assignment we have already discussed. So please, just the question is the formatting, the written in another form. Okay, so Deep is telling B, Bala is telling B, Ramesh is telling B. Okay, fine. Other student, please also you just try to write. Khagan is also telling B. Yes, mostly is telling B option. So yes, B here is correct. In the turbulent flow, you will see the laminar sublayer thickness, which is nothing but your viscous sublayer. Okay, now we'll move on the question number 6. So here, what is the momentum thickness for the boundary layer with velocity distribution small u by capital U is equal to y by delta. So here option delta by 6, delta by 2, 3 delta by 2, delta by 4. So please just try to write your answer in the chat box. Which option will be correct for question number 6? Okay, Deep is telling A option because why? Because we have already in the just previous question we have solved. It was coming delta by 6. We have already seen. So Ghosh is also telling A option. Okay, for this question no need to solve because already we have solved here. I'll just show you here. Here you can see the momentum thickness this and your uh, u by u, the small u by capital U was this y by delta. So once you will calculate, you will get finally delta by 6. So definitely here delta by 6 will be the correct answer. Okay, so next question is question number 7. Very important question. So such type of question you can expect in your final gate exam also. This is a very important question. In the laminar boundary layer over a flat plate, what would be the ratio of wall shear stress tau 1 and tau 2 at two sections which lie at distance x1 4 unit, x2 12 unit from the leading edge of the plate? So you have to tell here the ratio. The four option is given: 3, 3 to the power 0.5, 3 to the power 0.25, 3 to the power 0.33. So you have to tell laminar boundary layer. Remember please, within the laminar boundary layer, you have at two locations over the flat plate. This is your laminar boundary layer. So let us suppose here you have the x1 from this direction and here you have the x2. So x1 is 4 and x2 is 12. So here you need to find out tau 1, here you need to find tau 2, and the ratio of tau 1 by tau 2 you have to tell. This is the question. So I need answer from all sides, please. For question 6, the Bala was telling also A. That is fine, okay. Now I am talking about the question number 7. So please everyone, just try to solve, just try to think. If you not know the formulas and all, so you can just Google. If you not know, if you know, then you honestly you just try to calculate by your hand. Okay, Bala is telling B option 7, 3 to the power 0.5. Okay. Okay, Ramesh is also telling B option, 3 to the power 0.5. Okay, so let me just show you. So in laminar boundary layer thickness, always remember please, your tau is directly proportional to, let me just show you the 1 by root x. Here you can see tau is directly proportional to 1 by x to the power 1 by 2 also you can write, or x to the power 0.5 also you can write. So tau 1 by tau 2 is equal to your 1 by x1 0.5, 1 by x2 0.5. So x2 0.5, x1 0.5. So x1 is what? X1 is 4 and x2 is 12. If I am correct, yes. So x2 is 12 and this is your 4 to the power 0.5. So 3 to the power 0.5 will be the correct answer. So option B is correct here. Okay, you all correct. So now we'll move on the next one. Next question number 8. Very important. The separation of boundary can be prevented by, new question, providing a small divergence in a diffuser. Option B, providing a tripwire ring in the laminar region for the flow over a sphere. Option C, providing a bypass in the slotted wing. Option D, all of the above. So please just think on that and try to write your answer. Okay, Bala is telling option D. Other student, please also try to write your answer. Bala is telling D. Okay, fine. What about others? Okay, Deep is telling D option. So I am encouraging all, please you just try to write your answer, whatever you know. Okay, Ramesh is telling D option, fine. Okay, so let me just explain you. Yes, here all option is correct. When you will provide this small divergence diffuser and the trip wire ring in the laminar region and the slotted wing, provide a bypass in the slotted wing, you will definitely you can prevent the boundary layer separation. Now the next question is question number 9. A flat with a sharp leading edge, a flat plate with a sharp, here you need to write the plate, with the sharp leading edge is placed along a free stream of fluid flow. The local Reynolds number at 4 centimeter from the leading edge is 10 to the power 5. What is the thickness of boundary layer? Thickness of boundary layer here need to tell. Whether it is 0.63, option B 0.35, option C 0.28, option D 0.32. Which option will be correct? Please. Okay. So please just you try to write your answer. Okay, so I'm telling, okay, just you try to solve, please. A flat plate with a sharp leading edge is placed along a free stream of fluid flow. The local Reynolds number at 4 cm from the leading edge is 0.10 to the power 5. What is the thickness of boundary layer? So here you need to find out first if your Reynolds number is equal to 10 to the power 5, whether it is your up to that at 4 centimeter, whether your your boundary layer thickness is laminar or in transition or in the turbulent. If it is laminar, so here you have to write the formula for thickness based on your this laminar, which is already we have seen the delta is equal to 5x divided by root RE. In the previous question we have already seen if it is laminar. Okay, and if it is turbulent, then what will be the formula? In the turbulent also we have seen here, let me just show you. This was in, okay, in the previous assignment I think we have seen the formulas. I'll just show you here, no issue. Question 9 here. So your option is 0.63, but how? Yes, up to Reynolds number less than 5 is to 10 to the power 5, your boundary layer is laminar in case of the flat plate. So this definitely, this is your laminar boundary layer thickness up to 4 centimeter. So here your formula 5x divided by root RE. So here you can put very easily 4, that is 5 into 4, and 4 is centimeter. So you have to, because your answer is mm, so 4 centimeter means when you will multiply with 10, then you will get mm, that is 40 mm divided by RE, 10 to the power 5. So finally after calculation you will get 0.63 mm. So this is the correct. Now, okay, so for question number 10, aging of pipes imply which of the following? Aging of pipes implies which of the following? Decrease in the value of friction factor, increase in absolute roughness linearly with the time and hence friction factor, pipe becoming smoother with time, all of the above. Aging of the pipe. Aging of pipe is nothing but increase in absolute roughness linearly with time, hence the friction factor. Means your friction factor when the your pipe will get older, then what you will your roughness will increase linearly with the time. So remember please. And finally, your friction factor will be increase. For question number 11, when the fluid flow along a solid boundary, more and more fluid gets retarded in the vicinity of the boundary. This deceleration is due to high velocity of the fluid, high velocity flow outside the boundary layer, high velocity gradient which exists at and near the boundary, all of the above. For question number 11, just think on that. Important question, please. For question number 11, just please try to write your answer. Another question we have in this set 2024, then after we'll see the 2023. Okay, you are telling C option. Bala is telling C. High velocity gradient which exists at and near the boundary. Okay, fine. This option is indicating the no slip condition also, the option C. Okay. Other student please also try to calculate, or try to think on that and then you write. Not here the calculation. Ramesh is telling C option. Okay. Other student please also. Okay. So let me just show you the answer. For question number 11, uh, which option will be correct? Yes, option C is correct. Why? Because at the boundaries, your no slip condition is occur. Due to the no slip condition, your the velocity gradient is very high. So that's why the fluid get retarded in the vicinity of the boundary. Here details in the detailed solution, let me just read. When the fluid flow along the solid boundary, more and more fluid gets retarded in the vicinity of boundary. This deceleration is due to high velocity gradient which oh, similar the things here it is written, there is no information, only the question and the solution here it is written. Okay, no issue. Question number 12. The question 12 is displacement thickness of the boundary layer is. The formula here you need to tell. The displacement thickness. Which option will be correct? This is the last question for this your 2024 assignment. 12C. Okay. Bala is telling C option for the displacement thickness. Okay. Deep is also telling C option. Okay. Ramesh is also telling D option. Okay. You are telling the D option. That is fine. So yes, option D is correct. Option for displacement thickness, option C is correct here. Okay, so now we'll move on the next one, 2023. Okay, so for the question one is the nominal distance of a boundary layer is defined as the distance from the wall to a point laminar flow. Where the velocity is 99% less than the asymptotic limit, where the velocity ceases to be laminar, and where the velocity is within 90% of the asymptotic limit, where the velocity is 99% of its asymptotic limit. So which option is correct for question number 1? This is a new assignment again. So please just try to write your answer in the chat box for question number first. Very important question, please. This is another new question we have not solved till in both this your 2025 and 2024 assignment 2. Means here how we will select or how we will know up to that much height, this is your boundary layer thickness. Ramesh is telling A option, fine. Bala also A telling okay, where the velocity is 99% less than the asymptotic limit. Okay. So here your the nominal distance, okay, let me just show you. Option D is correct, where the velocity is 99% of its asymptotic limit. The boundary layer thickness is usually defined as a distance from the wall to the point where the similar thing is written. There is no need to, where the flow velocity reaches 99% of the free stream value. Means this is your boundary layer. So from here your velocity varying like that, the water is entering, so your velocity is varying like that. After that you will velocity is constant. Means here your velocity is 99% of this your free stream value. If here is free stream, so this is your free stream 99%. So this was the question. So option D is correct here. Okay, so question number 2. The displacement thickness of the boundary layer already we have solved. Option C was correct. That was the question number 12 in the previous one. Okay, so now we'll move on the next one. Question number 3. The ratio of displacement thickness to the momentum thickness of linear velocity distribution over flat plate. What will be the correct answer? Please. I need answer from all sides for question number 3. Just try to write your answer in the chat box. For question number 3, please. What is the ratio of displacement thickness to the momentum thickness for linear velocity distribution over the flat plate? Okay, Bala is telling A option 3, fine. Okay, Deep is also telling 3. Okay, 3 means you are telling option A. Okay, fine. Shreya is telling A option. Okay, all you are telling the A option. Definitely we have already solved this question. So the previously also for A option was correct. Why? Because your displacement thickness was coming delta by 2 and your momentum thickness was coming delta by 6. So after the ratio delta star by delta 6 theta, you are getting 3. Okay, so now next one. Here also the option mistake. So I think we have solved this question already. The boundary layer develop along the flow, the pressure decrease. Already we have solved. No need to. Okay. So next question. Laminar sublayer is a thin boundary layer. Already we have solved, which is in the turbulent flow. Laminar sublayer thickness we will see in the turbulent. Already we have solved. Okay. Next question. The momentum thickness for boundary layer with velocity distribution. Okay. So what will be the correct answer for question number 6? Okay, you are telling B option for question number 6, right? Deep is telling B option for question number 6. Shreya is telling A. Okay, Ramesh is telling A. Okay, Bala is also, Deep is also telling A. Fine. Yes, your option A is correct because we have already solved. And why? Because the formula you know. Your theta is equal to 0 by delta and U by capital U 1 minus small u by capital U. So once you will write here, the similar things I am repeating. Why? Because maybe some student will see when after uploading. So maybe that will be the good for others. Y by delta 1 minus y by delta dy. So after solution, what you will get? Y square by, after integrating, delta minus y cube by delta, and this is your limit 0 to delta. So delta by 2 minus delta by 3. So definitely we'll get delta by 6. So your option A is correct. Might be when you will after uploading, might be some student not see from your the first, the from starting to end. Maybe some student can see in the in between the last, or in between the whole 2 hour length. So that's why I'm solving. Maybe some student get confused what I'm telling. Okay, so nice. Now we'll move on the next question, question number 7. Okay, very important. So here you need to solve, please, because here the digit is different. So in the laminar boundary layer over the flat plate, what would be the ratio of wall shear stress tau 1 and tau 2 at two sections which lie at distance x1 is equal to 2 unit and x2 is equal to 10 unit from the leading edge of the plate? Tau A option 5, B option 5 to the power 0.5, C option 5 to the power 0.25, and D option 5 to the power 0.33. Which option will be correct for question number 7? Okay, so I am expecting answer from your sides. Just without solving, you can also think what is the correct answer. No need to solve for a student what to ever. We have already solved this question actually, so you no need to think much. Okay, so Bala is telling B option. Ramesh is also telling B option. Okay, okay, Deep is also telling B. Okay, for other student, let me just solve. So here you know already tau is directly proportional to 1 by root x, means 1 by x to the power 0.5. If tau 1, then x1 to the power 0.5. If tau 2, x to the power 0.5. Now for tau 1 divided by tau 2 is x2 divided by x1, power 0.5. So x2 is 10, x1 is 2. So here is 0, your 5 to the power 0.5. So option B is correct. Remember please. Option B is correct for this question. Next. Next is question number 8. The separation of boundary layer take place when the pressure gradient is negative, positive, zero, constant. For question number 8, your separation of boundary layer take place when the pressure gradient is positive, negative, and negative, positive, zero constant. For question number, I think Deep is telling B option, positive for question number 8. Okay. Ramesh is also telling B. Other student, please also try to think and try to give your answer because we have already solved this question. Other student, please also you just try to write your answer in the chat box. Okay, Bala is also telling B option, fine. That is positive. Your boundary layer separation will happen when your velocity, the pressure gradient is positive. That is del P by del X is positive. So remember, if pressure is increasing, then your velocity should be, so these both condition is need to be happen for the separation of boundary layer. Next, the velocity gradient is negative. Here you can see the flow separation occur when the pressure gradient is positive and the velocity gradient is negative, less than 0. Next, question number 9. So you have to solve. Question number 9. Flat plate with a sharp leading edge is placed along a free stream fluid flow. The local Reynolds number at 3 cm from the leading edge is 10 to the power 5. What is the thickness of boundary layer? So just think on that. Here is the distance is 3 cm from the leading edge and Reynolds number you are getting 10 raised to 5. So what will be the correct one? Okay. For question number 9, you please just try to calculate and then you try to write your answer. For 9, okay, Bala is telling A option 0.47, fine. Other student, please. Okay, Ghosh is telling A option, fine. Okay, Deep is telling A option, Ramesh is telling, okay, everyone telling the A option. Might be A option will be correct. Let me just check. Yes, A option is correct. But how? You know, at Reynolds number, when your Reynolds number is at the leading edge is equal to 10 raised to 5, you know already the Reynolds number is when the less than 10, 5 into 10 raised to 5, then it is laminar boundary layer. Laminar boundary layer. So it is in laminar. In the laminar boundary layer, your delta is 5x divided by root RE. So here 5 into 3 and you need answer in the mm, so multiply with the 10 divided by 10 to the power 5. So after calculation you will get 0.47 mm. You can just think on that. Even it is not 1 mm, please. Even it is not 1 mm, 0.5 mm, the thickness. So you can just imagine the what is the thickness, very thickness, very thin. Even whatever I am drawing this line, it is 1 mm. It is 1 mm. So less than this, the half of this line, your boundary layer thickness. Just for a study purpose, we draw the boundary layer like that. But this is not. Actually, this is very near. Even you cannot draw with your pen. Remember always, please. But for a study purpose, we try to show in the zoom view. So a student can understand. Always remember, please. Okay, so now we'll move on the next question. This is new question. The velocity profile for turbulent boundary layer is given by ux divided by capital U is equal to y by delta raised to 1 by 7 for y less than equal to delta. This formula is for this, for less than equal to delta. The shape factor for turbulent boundary layer will be, here you need to calculate the shape factor. And what is shape factor? Might be this is a new term, so I'll not wait here. So I'll just move on the final answer. Let me just show you the formula. Okay, so shape factor is nothing but this is your delta star by theta. And what is m plus 2 divided by m? Means what is m? U by ux capital U is equal to y by delta to the power 1 by m. So this m is m plus 1 by m plus 2 by 2. So m is here 7. So 7 plus 2 divided by 1, that is 7. So you will get 9 by 7. If your velocity distribution, so option B here is correct. If your velocity y by delta was, oh sorry, delta was, let us suppose here 2 by 10. So what will be the value of m here? What will be the value of n? I need answer from your side, please. What will be the value of m here? If you have y by delta by 2 by 10. So whether it is m is equal to 10 or other, you just try to write. You just type your answer, whatever you are thinking. Yes, 5, definitely, because you have to maintain 1 by m. You have to maintain 1 by m. Based on 1 by m, this is the formula. So if it is your 5, m is equal to, here you will write y by delta is 1 divided by 10 by 2. So this will be, if here was 3, then what will happen? The 10 divided by 3. Then whatever you will get, so this is your, finally m will be 10 by 3. So 10 by 3 plus 2 divided by 10 by 3. Then final answer will be give the shape factor. Okay, leave it, but your here 1 by 7, so based on 1 by 7 it your answer is your 9 by 7. Remember please, this is very very important. Now the next question, question number 11. When the fluid flow along a solid boundary more and more, okay, we have already solved this question, high velocity gradient, that is no slip condition, this is your due to the no slip condition. Okay, so next question, this is the last question for today. In turbulent flow, which of the following give the exact velocity distribution? Already we have seen logarithmic, Velasius, power law with index varying and the Prandtl's 1/7. So already we have seen. So I need answer finally from your side. Everyone just you write your answer in the chat box. In turbulent flow, the velocity variation follow which law? Whether logarithmic, Velasius, power law or Prandtl's. Okay, Deep is telling A option, logarithmic distribution. Other student, please. Okay, Ramesh is telling A. Bala is also telling A. Okay. What about Ghosh? Yes, in the laminar, in the turbulent flow, always this the logarithmic distribution. Already we have solved this question. So, okay, thank you for today. So we have already solved the three questions, three set. That is the total question is I think 34 question. Okay, fine. So that is good. So we'll meet again in the next session on Sunday. So thank you. So now you can leave the class, please. Okay, thank you all. I'm closing the session.